Hello friends, in this video we will discuss about isomeries. What is isomeries? The phenomena of existence of two or more compounds possessing the same molecular formula but different properties is known as isomeries. Such compounds are called as isomers. This is the classification of isomeries. Isomeries is broadly classified into two categories. First one is structural isomeries and second one is stereoisomeries. Structural isomeries further classified into four. That one is chain isomeries, position isomeries, functional group isomeries, metameries, and stereoisomeries classified into two categories, geometrical isomeries and optical isomeries. Now we will discuss one by one. First come to structural isomeries. Compounds having the same molecular formula but different structures, manners in which atoms are linked, are classified as structural isomers. First come to chain isomeries. When two or more compounds have similar molecular formula but different carbon skeletons, these are referred to as chain isomers and the phenomena is termed as chain isomeries. For example, C5H12. This represents three compounds. CH3, CH2, 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 CH3. This is pentane or normal pentane. And this is the chain isomer of this C5H12, isopentane, and its IUPAC name is 2-methylbutane. Another structure is this one. This is neopentane, or its IUPAC name is 2,2-dimethylpropane. So we can say C5H12 has three chain isomers: normal pentane, isopentane, and neopentane. In normal pentane, 5 carbon atoms are in a main parent chain. In this case 4 carbon atoms, and in this case 3 carbon atoms in parent chain. Another structural isomerism is position isomeries. When two or more compounds differ in the position of substituent atom or functional group on the carbon skeleton, they are called position isomers, and this phenomena is termed as position isomeries. For example, molecular formula C3H8O represents two alcohols. This one is CH3, CH2, CH2OH, and its name is propane 1-ol. In this, we start numbering from this carbon atom to which OH is attached. So, this is propane 1-ol. And this is the another compound CH3CHOH CH3. Now, in this case, if we give the numbering, then at the second carbon atom, at the second carbon atom, OH is attached. That's why this is propane 2-ol. You can say this is carbon skeleton is same, 3 carbon atoms. In this case also 3 carbon atoms, but the position of functional group is different. So these are position isomers of each other. Another example, C3H7Cl. This represents two compounds, CH3, CH2, CH2Cl, and its name is 1-chloropropane. And this is CH3CHCl CH2. This is 2-chloropropane. Again, this skeleton is same, but position of chlorine is different. In this is attached to the first carbon atom, and in this is attached to the second carbon atom. Functional group isomeries. Two or more compounds having the same molecular formula but different functional groups are called functional isomers, and this phenomena is termed as functional group isomeries. For example, this molecular formula C3H6O represents an aldehyde and ketone. Actually, aldehyde and ketones are functional group isomers of each other. Like this C3H6O, we can write propanone, CH3COCH3. This is ketone. And we can also write CH3CH2CHO. This is aldehyde and its name is propanol. Both are functional group isomers. Alcohols and ethers are also functional group isomers of each other. For example, C2H6O. This formula represents CH3CH2OH, this is ethanol, that is alcohol, and this is CH3OCH3, its name is methoxymethane, this is ether. Okay. Metamerism. It arises due to different alkyl chains on either side of the functional group in the molecule. For example, C4H10O represents. This is actually, this is ether and this is also ether. And in this C2H5 alkyl group and this is C2H5 another alkyl group attached to this oxygen. Now, with the same molecular formula, we can also write this one. Now, to this oxygen, one side CH3 and one side this is C3H7. Okay, so different alkyl groups are attached to this oxygen. This is ethoxyethane and this is 1-methoxypropane. Another example, C5H10O represents. This is again ketone. In this case, this CO is the functional group. Okay, to this carbonyl carbon, one side this is CH3CH2, that is C2H5, and another side again this is C2H5 and its name is pentane trione. Now another structure is, this is again functional group CO, one side methyl group and another side this is propyl group and its name is pentane 2-one. These are metamers of each other. Stereoisomerism. The compounds that have the same constitution and sequence of covalent bonds but differ in relative positions of their atoms or groups in space are called stereoisomers. This special type of isomerism is called as stereoisomerism. It is classified as geometrical and optical isomerism. About this geometrical isomerism we will discuss in the next chapter, that is hydrocarbon. And about this optical isomerism we will discuss in the class 12th. Okay, thank you. Subscribe my channel to get the next video from this chapter.